Sorry, that's my fault. Okay, so I'm going to talk about LinkedIn in just a few minutes. But before we go there, I'm going to go to syllabus. So syllabus is essentially this README file that's displayed here. The repo for this class is this URL here, github.com echild-in paste-u-cs67. And that's the URL. And that's the only thing that I'm going to use for this class. I'm not going to, except for LinkedIn. And that's the only thing I'm going to use in this class. The school's system, I'm going to use it for announcement and probably only announcement. And that's it. So class material, code, there's not slides, but other classes, there are slides, and they're all on GitHub. Make sense? And then most of the submissions will be online, and I'm going to talk about that in just a sec. But everything is pretty much here. This class, it's mostly building things, building projects, building apps, building chatbots, building whatever you like, right? It's going to be building things. So there's no real homework. The homework is basically the app that you build. Make sense? And then today we have Hugging Face. We have all these fancy websites that's open source that allow you to deploy things. Just deploy there, and then just use a URL, and that's literally your submission. Make sense? So it should be, and of course, if you have no idea what I'm talking about, I'm gonna show you guys what that means, and then hopefully everything will be clearer as we move forward in the class. Okay, so in terms of projects, this is kind of like abstract thing, but in terms of projects, it's all in this folder called Capstone. Oh, by the way, this is the main branch. When you are navigating to this page, just make sure you go to the 2025 fall branch, because I like to keep every semester separate, and then sometimes there are things I do differently from time to time. So just make sure you go to the 2025 fall branch. So it's here. And then you can then click in Capstone. And then most of the deliverables is here. So deliverables is here. I don't have the exact timeline yet, so bear with me on that. I'm going to work out a timeline, and then I'm going to let you guys know what each of them, well, first of all, in what order, and then what each, at what time is each deliverable due. So I'm gonna tell you guys all of that. And usually the deliverable is due usually the deliverable is due like 2-3 weeks ahead. Like I'm not gonna say something like, oh yeah, this is submitting tomorrow. Like I will never do that. Like usually my deliverable is pretty lenient. It's usually 2-3 weeks ahead. And then I don't expect a whole lot. There are, roughly speaking, 5 like big topics on a high level. Each topic has its own purpose. I'm expecting you do roughly 2 to 3 throughout the semester. And then in the end of semester, there's like a big submission. And then pretty much all the weight is on that big submission. So if there's any deadline in the middle that you missed, don't worry about it. Like it's not the end of the world. The only thing to do, the only downside to that is, let's say there's a deadline that I said first week of October, there's a deadline, right? And then for some reason you miss it, right? Let's say that's the case. Not to worry. The only downside is I didn't get to see your assignment, so I can't really provide feedback. That's all, right? And then I'm sure all you guys know is the pass fail, right? There's no ABC, right? There's pass fail. So pretty sure everyone here is gonna pass. Like my grading is pretty lenient. Like people take my class before, my grades are pretty lenient. So pretty sure everyone's gonna pass. So if you miss assignment, don't freak out. Like we're here to learn something. I hope you guys learn something, and that's why we're here, right? So let me talk a little bit about these 5 topics and why they're designed this way. The first thing that we're gonna start is Gradio. Gradio, it's basically supported by Python. It's a company that builds packages to build a front-end interface, or also known as user interface. And then basically it just means everything's convenient, right? Because everything is in Python, just one single language. So you build a backend in Python, you build a frontend in Python, and you're done, right? And also in Python is the most common language, which means there's more data on Stack Overflow, which means all the data is already trained using large language model, which means you can talk to large language model, right? So Gradio is extremely convenient. Like I had a student that never touched Gradio at all and just talked to chatbot, and then chatbot was able to do a Gradio app for them. And then hopefully I can demo that in front of you guys, and hopefully there's no error. But basically chatbot can probably get you like 95, even 99% to the finishing line. If you're clear on your prompt, you should be able to design an app in pretty much whatever way you want, as long as you're clear on the prompt. And I'm going to talk a little bit about what do you mean by clear. There are certain ways that you can write a prompt. And then the short answer is you have to think like a programmer. So if you have programming experience before, you can write a prompt in a way that you think like a programmer. So that will come more natural for a computer to write a code for you. If you're a non-programmer and then you write a prompt in a way, hey, come on in. If you're a non-programmer and then you write in a way that it's not native to how programmer thinks, then obviously large language model will have a little difficulty getting the code right. So we're gonna talk a little bit about that. So that's Gradio. Gradio is kind of like the most basic thing, right? If you want to build an app, you have to know some front-end language, right? You have to know something. It can't just be like a Python script or Python notebook, right? So that's what Gradio is for. And then from here, I would say you can go two directions, right? One direction is you have some sort of data, and the data can be some sort of curated data by yourself, or it can be some sort of a database locally. So you have a database local, then obviously you use SQL, and then SQL can be plugged in MCP, which is also known as Model Context Protocol. And then you can use MCP to write SQL code for you to basically query the data, right? You can build all this using ChatGPT. So that's there. And then the other direction is you can say, hey, I have a piece of data that I don't want the public to know. And these is usually private data. Maybe it's because you're working for a company. Maybe it's because this is data that's highly valuable. You don't want to leak on the internet. So obviously you will fine tune your own large language model. And then there's a package here. I actually designed this package myself. That's pip installable that you can very quickly fine tune your own large language model in like a small framework very efficiently, so that you can quickly get the experience of fine tune something, change your weights a little bit according to your data, and then kind of see like the information from a data set reflected in the output of the large language model. And then this is also nice, and some students enjoy it because you get a check on your resume, say, hey, I fine-tune large language model, and then I've done it before. I know the know-how, right? So it's kind of nice. So once again, just to recap, start with Gradio, so you have knowledge of designing the front end, and then you can go two directions. You have data, and you're not afraid of using data. Then these two apps. But if you don't want data to leak out, you fine-tune your own data, fine-tune your own large language model, then it's this folder. Now, let's say everything's done, right? Whatever direction is, let's say it's done. You have your app, you have your chatbot, you know what the chatbot looks like. You can slash voice on top of it, and that's what that folder is. Make sense? And then since MCP, usually MCP is like a separate topic, but I built MCP in here just to make things easier. So you don't need like another folder to just talk about MCP. You can't really talk about MCP without a particular tool either, because MCP is all about tool calling, and we're going to talk about that as well. So those are the projects that we're all going to talk about this semester. And then hopefully, I will try my best ability to explain all of these things in front of you guys and do demo in front of you guys. And then hopefully I can explain these things in a way that you guys can understand it and reproduce it. And then when you go into an interview, you have a story to tell. Make sense? Any questions? Good? Okay. So those are the projects that's upcoming, and then I'll tell you guys the deadline, all that stuff. And then in the end of semester, you guys are gonna be submit like a big app, right? The big app kind of just depending on what you want. You don't have to do all five. You don't have to do all five. Does that make sense? You can say, hey, I'm gonna fine tune a model and I'm gonna put voice on top of it. Be done with it. You can pick 2 out of 5, 3 out of 5. Does that make sense? only do 5 out of 5 if you have time. So that's that. Any questions about that? Okay, good. And then what time is it? 6:38. Okay. So typically what I would do is this. Um, I don't do 3 hours because let's be honest, like no one's gonna pay attention for 3 hours, right? That's not gonna happen. So typically what I do is I will talk for about an hour, take not even an hour, I probably talk about 50 minutes and then take a 10-15 minute break, and then we'll come back and I'll talk for another maybe 50 minutes, if that. And then we'll call it a day. Make sense? It's Friday, get out. Like I don't know what you guys do, but get out. Can you guys drink? Okay, so for those who are over 21, go to bar. For those who cannot drink, go back to your dorm. Um, okay, so we have a few minutes. I'm gonna dive into Gradio a little bit. The folder is here. I haven't really added anything here, but I will add things as we move forward. The most important thing that I can highlight here, and we're gonna jump into code, obviously, but the most important thing is I would say just go to Gradio in general. And then this is the Gradio website. What I find interesting is the quick start and playground are usually something very interesting, and they will quickly give you like a template to work out of. So I usually find those things interesting. What else is interesting? If you go to the Hugging Face, there's like a list of Gradio apps that you can do. I can show you that real fast. So Hugging Face. If you go to Spaces, and then you can go by different categories, and then each category will you can rank these apps according to like whatever, like relevance, number of likes, trending, or whatever. So for example, like image generation, that's the first one. I can then sort by trending. Oops, trending. And then typically I would just start clicking down these apps one by one and then see if it works, if it doesn't, if you're using GPU. Ideally, you find something that you can get away with without GPU, because GPU obviously, you pay for it, right? It's not free, right? Like for example, here, the first one, it says this thing 0. 0 just means you need a subscription. And the subscription for 0, I believe it's $10 per month. Don't quote me on that. Fact check on it, but it's like $10, might be $12 a month, something like that. But you can just start playing around with this. I'm just gonna click on a sample problem. That's Yan Le Kun, and then we'll see generate. I actually don't know what this does, and it's just a random app I click on. What does it do exactly? Oh, it's using the prompt to decorate this picture. So the man in the flower shop carefully matches bouquet, combining beautiful emotions and blessing with flower. So the picture is a man, assuming there's some sort of flower. So that's one application that you can do. Behind the scene, obviously, there's some sort of a multimodal model that accepts a picture and also accepts a sentence, which it's a string. In Python, a sentence is basically a string as input, and then it makes an inference, and then inference is basically a new picture. So that's basically, it will immediately tell you what that model is, and then it will immediately tell you, hey, this is kind of like the user interface that you can use to build it. And then one thing I found interesting is you can, of course, look into files, because Hugging Face is open source. Open source just means all the code is out there in the public. So you can copy the code, you can run it yourself. If you are running locally with a CPU, obviously it's slow, but you should be able to run, assuming you install everything correctly. And then another thing I found interesting is this is 3 dots on top right corner. You can click on, and then you can duplicate the space. And then once you duplicate the space, it will be on your own account. Now, depending on if you have a subscription, so you may or may not have the GPU, but basically duplicate the space will migrate, sorry, not migrate, it will copy this code and then create a repo that's the same code on your own account. So then you can like play around with it without affecting the original repo. So that's something that's quick and dirty that you can play around, just to quickly gain understanding. Any questions? Good. Okay. That's that. Let's go back to this. Okay, that's Gradio. In terms of data curation, let's see. So in terms of data curation, I have a repo here that basically what I did was I downloaded all the Warren Buffett letters because I'm a big fan of Warren Buffett. Warren Buffett, I think he has a certain way of investing, value investing. We all know that. The premise here is okay. Obviously, Warren Buffett is doing something that only he knows, that's not written on paper. Fine, then that belongs to him. I don't know if you guys know, Warren Buffett actually never wrote a book. So that's something very interesting, right? Which means what? Which means all that stuff he learned from Ben Graham, sure, he learned it, but he also, throughout the years of investing, he created this synthesis in his mind that is not on paper at all. So he himself is the strategy. Make sense? So there's something in his brain that's not out there. So that's my premise, right? That's my premise. Now, of course, you can say, hold on one sec, that you don't know if that's true. He could just be using public information, and he could just be using making decision based on everything that we already know, right? You could make that argument. Totally fair. You can, right? That's what this is about, right? If I'm scraping his letter and I'm able to build a model that somehow knows the stock market in a way that's not the average of the stock market return, then that means the letters that about his company Berkshire Hathaway is doing something that the market is not doing. So the result, which is crucial, if I'm able to pull that off, if I'm able to train that model, then that means Warren Buffett knows something the market doesn't. If I and this is a big if, right? If I use all my GPU power that I have, and I put in all the manpower, and I try my best to train whatever model that I can based on his annual letter from Berkshire Hathaway, and it turned out it's exactly the same as stock market, then maybe that means that Warren Buffett is just doing things that the average people knows, right? But you won't know that. You don't know what you don't know, right? But you won't know that unless you go through this experiment. Make sense? Any questions? So that's what this repo is. This repo actually just give you data. It actually doesn't talk about the modeling part. So I kind of left it that way because usually data is the difficult part for students because to process the data you need a lot of compute power. And then I can show you guys real fast what that look like. So this is the repository, and you can duplicate this, install a package. You can run this whole thing. The only thing difficult is the GPU. So to do this, first of all, you need a PDF, right? Once you have the PDF, you need to scrape it and then chunk it into different sizes. And then the chunking has a little bit of art behind it. You can also call that bias. I typically like every 2 to 3 sentences because that's just like if you show me 2 sentences, I'll probably read it. But if you show me 4 sentences, I'll probably not read it. but that's just me in person. No guarantee that's the same with all of you guys, right? So I'm certainly throughout these steps, there's my personal bias. Make sense? So the reason I'm saying that is because I'm telling you guys this is not the perfect way. This is just a way to do this. Make sense? So you take the PDF, you chunk to different sizes, and then for each size, for each chunk, you say, okay, you make an API call. You say, okay, what is the question based on this context, right? And what is the correct answer based on this context? And then please give me an explanation. So you make 3 API calls for each chunk. And imagine this guy has I don't know, 10, 15 years of letters. And then each letter is I don't know, 15 pages or something like that. And then you chunk it, each page will probably give you hundreds of thousands of chunks, right? And then each chunk will give you 3 API calls. That's a lot of API calls. So you can easily exhaust token to a point that probably student can't afford. So that's why I did this here. So that's the procedure. And then you can go up here to the code is here, by the way. So the docs is here, and then the results are here. So I can show you real fast what this look like. So this is kind of like what it look like. First of all, the file format, the JSON-L just means list of JSON. That's all there is. And the list of JSON just means you have array of these curly bracket, and that's what the data look like. And whenever you see that data structure, that's usually JSON-L. And JSON-L is a standard structure if you want to fine-tune a large language model. And then the structure is this. Inside of each curly bracket, there's usually some sort of a context. So that's why you start with Markdown. Markdown is just whatever is being scraped from that paragraph, right? If it says Berkshire Hathaway Inc., then it says Berkshire Hathaway Inc. And then if you scroll to the right, there should be question and answer. Let me see if I can find it. It's quite long. Dun, dun, dun. Where did it go? Or maybe I use a different tag. Hang on one sec. Oh, I remember. I'm sorry. This is just a scrape. There's no question answer. Question answer is on Hugging Face. I'm sorry. I take that back. So sorry about that. This is just the scraped raw pages. Make sense? So it's kind of like the text format of the PDFs. So that's what these things are. And then the letters are all here. So these are all scrapes. I think I did something 20 something years, not a whole lot, but 20 something years, 24, maybe 26. Yeah, 20 something years. So it should be plenty of data. And then the data is online, by the way. These are the links of PDFs. So if you click on these links, it should take you to the original letter. And this is the original letter by Berkshire Hathaway. You can see the URL here. That's berkshirehathaway.com. And that's where the letters come from, right? So this is trademarked by Berkshire Hathaway. Like you can kind of take for granted that Warren Buffett read and probably wrote some of this stuff himself, and then he will take this as like gospel, basically. So that's the source of data. We're scraping it, and once we scrape it, it looks like this. It looks like these things, JSON-L format. And once you run this through LLM, generate a question answer pair, it will look something like this. Let me find the link. I should really drop the link here. Oh, here. I thought I did. Yeah. So it will look like this. So you have question, answer, and reasoning. You can click on any single one. And then the question is basically something like this. And then this is the answer, and this is the reasoning. So when you train a large language model, you will ask a question that looks like this. It doesn't have to be word by word, but this is kind of like the input. This is the output, and then the output also contains this. So you can think about it as one input and one or two output. You can also concatenate this together to be one output if you want. You can do separate if you want. Typically, people just combine this so you have one output. But that's pretty much what the data look like if you want to fine tune some sort of large language model. So it doesn't have to be Warren Buffett, but usually that's the drill that people do. Any questions? Good. Okay. I think I have a few minutes. Let me talk a little bit about the other things. Let me talk a little bit about this. This package is basically a repo I coded to help you scrape the data and then kind of like fine tune yourself. So this repository has 3 notebooks. The first one, scrape any PDF. So you upload PDF, you'll scrape it. And then you will generate a question answer pair. And then question answer pair is basically just the previous page that I just showed you guys. And then you will fine tune a Llama 2 model. The reason Llama 2 model is just because Llama 2 is smaller, less weights. So you can probably get away with like a Colab notebook with like a T4 GPU for free. You can get away with like 30 minutes of training time, just something small scale to get your hands dirty. But obviously, you can make the argument that Llama 2 is not as advanced as, say, Llama 4, right? And then step 3 is just inference. Because if you cannot do inference, then what's the point of training model, right? You have to run some inference. Inference just means making a prediction. Like once the model is trained, now I can talk to it. And when you talk to it, that process is called inference. So step 1, 2, 3, and they're all here. Okay, let's take a break. Let's see. Right now it's about 53, so let's come back at 10 at the clock. 8:10. Wait, I'm sorry, 7:10, 7:10. So as I was saying, it's painful to get into a new project and then read the code very efficiently to understand what's going on. But that's where AI comes in, right? You can use this Copilot on VS Code, same thing. Or I find it very helpful to just use Claude. So let me show you what it's doing. So go to Claude. It will open a command line interface style chatbot that you can talk to it. And then you can start saying something like, I'm in a directory and I think it's an app, but I don't know the architecture. Can you read it and give me a blueprint of what the app is doing? Typically, people will probably stop there. The way I like to do it is I will probably give a bit more information, right? I will say, do not change any code. Only give me information in response. And then please give me a diagram that is ACSII style. The ACSI style, if you don't know, it's a style of drawing pictures, specifically it's a style of drawing diagrams in the terminal environment, right? It's highly rudimentary. It's literally just the keyboard like bar thing. And then you just use a keyboard bar and star and whatever to draw the diagram. That's it. So whenever you see that, that is called ASCII style. And then, yeah, that's pretty much it. And then you can, hang on. And then it's gonna give me a summary. And then on top of that, it's gonna give me a picture. So we're gonna wait a little bit and see what the picture look like. I tried this before class. It should be able to give a picture that kind of points out the relationship between this Python script and this Python script. Because if you look at this and if you just think a little bit more, you don't need to understand what's going on here, but if you just think a little bit more, there's only 2 Python script here, right? .py. So there's only 2 Python script. So whatever the magic is, it has to be in there, right? That's the reasoning. Whatever the magic is, it has to be in there. And why is there 2 Python script? Well, one probably will call the other, or vice versa. Even if you don't understand what server means, there's only 2 Python script. One has to call the other. Otherwise, what's the purpose of writing a second Python script? I just put in one script, right? So that's pretty much that. And then so before you touch anything, you should and before you read into any single code, you should kind of know there's some sort of innate relationship going on here. And that's why people do things this way, right? So now we're talking to it, and then you can probably scroll up. I don't know how clear this is. It might be the font size. Let me see. Okay. So here, the box is probably messed up because I zoom in here on terminal window. But it doesn't matter. You get the idea. So the relationship goes from top to bottom. That's how the style is orchestrated. So you have a user authentication purpose. So immediately out of the box, you know, okay, this app is probably handling logging. That's what this app is doing. User authentication means logging. Login, log out, like all that basic stuff that you need to design a SaaS software, right? Front end means what users see, buttons, text box, forms, like that sort of thing. This Python script is Gradio, okay? So we're talking about Gradio app. So that's why this is .py. So it's Python based. port 7860, that means it's a local port using that range. So if you fire this up, right, deploy or run app or whatever, you should be able to go to a browser and type in localhost 7860. So that's what that number means. And then it kind of shows you what the app look like. Okay, so there's a home button, excuse me, there's a home tab, there's a register tab, there's like login tab, whatever, and there's a profile tab, and then so on and so forth. There's like a bunch of other things that you can click on. So this kind of tells you what the user interface look like. Make sense? And then down here, it says API, right? API basically means, so API stands for Application Protocol Interface. It's essentially an endpoint that you can send data and get some data back. So that's what API is for. And then API just means whatever the button that you're clicking on, it needs to do something, right? You click a button, you say login. Then what that means is it reads the username and password and check if that exists in the database. And if it exists, are they the same? If it's the same, that means you have account, and then you can log in, and then you will say login successfully. So that's what this is. That's what this box says. That's what that class object is. And then in the end, it will make some sort of a REST API call. And then all these stuff is happening behind the scene. This endpoint is the endpoint of the server. So when you make an API call, it's going to say HTTP blah 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 A001. So that's the endpoint of a server. And then this is the most important thing. If you forget everything in this class, that's fine, but you have to know this. Because if you don't know this, you're not gonna like you can't find a job. Like this is the first thing. Like when we interview people, this is the first thing that we ask. Have you handled like a full-on REST API request? So what are these things? So let me walk through one by one. There's only 4 requests for an API call, right? There's a get, there's a put, there's post, and there's delete, right? So we're gonna talk about one by one. Get. What does get mean? Can anyone guess what does get mean? Just think about like in terms of English. When I say I'm getting something, what does that mean? Correct. You're getting a data back, right? You're getting data back. That's it. That's all there is. So if you want to say, oh, does the user exist, right? When you want to handle that kind of API call, it's usually a get API call. It's a get request. Okay, now put. What does put mean? Anyone know? Exactly. You're putting things into the database, right? So you're uploading something. So when I register account, usually that's put request. Make sense? Get and put together, it's basically post. So post can do both things. That's what post is. So you have get, you have put, and you have post. Last one is kind of like self-explanatory. Delete is just delete, like you're removing things from a database. Make sense? So that's literally it. So you have to know all 4 of them, and then you have to know them well. Can anyone guess when you make an API call? So let's go back to the website. Can anyone guess what this is? What request? We have 4 requests, right? Which one of the 4? Is it true though? Yeah. It's both get and put, right? Because you need to send some data onto the platform. And then you also need to get some response back, right? Like we're talking about chatbot, right? You talk to it. Right. So if it does both get and put, then what is that? Exactly. So a chatbot is typically a post API call. Make sense? Okay. So in the industry, like people like me, we serve API like this. When I say I serve API, I meant that I write some code, and that code contains these 4 requests, and then these 4 requests then need to be baked into the URL endpoint. That's called an API. And then I need to tag API key, throughput rate, how much I want to charge people, and all that, like all that stuff in behind this one function, and then serve that function. And then I can tell my client, tell my customers, say, okay, the code is ready, the product is ready. This is the instruction manual, and this is how you get some data out of the database. Make sense? So what I'm showing you in the terminal, what I'm showing you here is what's happening behind the scene of when you make an API call using ChatGPT's OpenAI API docs. Any questions so far? Okay, great. Okay, so now this is kind of like the boring part. Now let me do the fun part. So sorry, not the fun part. Like this is still the boring part, but you kind of have to know this. Okay, so this is a server script and this is the main script. So let me move them side by side. I can do things this way. Okay. You don't need to read every single line of code. There's a trick of reading this that make your life easier. Okay. First of all, you already know server is the back end, right? The main is the front end. Like that, you know just by this name here. So, for example, if you want to start server, maybe there's a button called start server. If you want to stop server, maybe there's a button called stop server. And then maybe there's like create interface or something like that. And then if you look into this, that should be where the front end is. And then the front end, you actually don't need to understand any of this because the Cloud Code can write it for you. But there's like a basic structure, right? For Gradio, it works in a very similar way as HTML. So you can kind of see, okay, blocks, whatever that means, right? Blocks means something, right? The something in the container. And then Markdown just means you write a title. That's what Markdown means. Tab just means there's a button on top called tab. And then in that tab, it is very, 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 very HTML, very much like HTML. There's a row and there's a column. So you're kind of looking at you're looking at the code as if you're looking at a map. It's a great structure, right? With row means one row, and then with column means in that one row, there are different columns. So literally, I'm looking at the line like a banner, and on that banner, like different tabs. So that's what the relationship is. That's it. That's all you need to know at this point, right? You don't actually need to read into this. Only when things go wrong do you read into this. So backend. First of all, you know it's user authentication. That implies there's a database, right? I hope everyone here like touch upon database before, but if you haven't, that's totally fine. That's why we're here. I'm gonna upload this code onto the GitHub, and then obviously I'll share the link with you guys. I would say handling database is probably the most basic thing that you have to know as a data scientist. Typically, typically in the industry, the first job that people will have you do, assuming that this is your first job, like my first job as data scientist, literally day one, they say, okay, we have a database that's broken, fix it. Right? That's the first job. Or we don't even have a database. Well, then too bad, you got to stand up database yourself, right? Stand up database means there's a container somewhere, and then there's like a nice table somewhere. If it's one table, if it's more than one table, then we're talking about relational database. Then that's a little bit more complicated. Then it's a common key and all that stuff, right? And then once you have a database, right, whatever table that you want to store, and then you can talk about what do the API calls look like, right? So every database has to have API call, right? Otherwise, what's the point? You can't just save data somewhere and not use it, right? Like you have to use it and have to allow other people to use it. So that's what this is about. And then on a high level, this is how I will read this if I'm first time reading this. These things, usually I will skip that. Because you read the repo, usually there's like a requirements file and that will tell you what the package is. That's why typically I skip this. I will see database and I know probably this script is talking about database. So I will read that and I will skip all the way to probably here. This just tells me the schema of the database, right? So how do you define a user? Well, you define a user if the user has ID, username, email, password, and whatever these things are. So that's basically the schema of the user. And then these things typically I would just skip. Why would I skip that? Because I know that these things are just metadata that helps me define what these data look like. That's it. If you memorize this, it's helpful, it's not helpful, not really at this point. It's helpful when you're debugging. But if you're just reading this to understand the logic, th this is not that helpful at the moment, right? So you can skip this for now. And then since I know it's a database, then the next thing I'll be looking for is those 4 requests: get, put, post, delete. So I will scroll down here until I see this. So this add symbol and then say app.get, that is a get request. So get request is something you have to like write in a script so that the API knows that when people do a get request, that's the function that they execute. Make sense? And these can all be customized. Like you can have an app that has like multiple different get requests or multiple different pull requests or post requests or whatever delete that you want, right? So all that can be designed. Post is register because I'm sending data. I think earlier we said put, right? Here is post. Logging is also post because you're sending data up there. The reuser is just a get request because I'm not sending data. I just want to see who's there, right? Put is here's a put request for update user, things like that. And then you should get the idea like what the script is, right? Like you read a few and then now it starts to get boring, and you should feel that way because these are just repetitive things that people are designing to make the API call a bit more complete. Make sense? So now you understand back and front end. Now I can show you what the final thing look like. So you go to your terminal window, and then make sure where I'm in the right location, and I say uv run main.py. This should be able to run an app that is using this port. And I'm going to move this. It pop up on this screen, so I'm going to move this here. So that's what this look like. And then the first thing that you do is start a server. I'm hoping this works. Let's see. If it doesn't work, I have to manually trigger it. Okay, so you start a server on 8,000. 8,000 makes sense because that's what the code tells us. Let's go back here. 8,000. So that's in the script. So that makes total sense. And then you can then register. So you can say start to, say start to gmail.com. I'll just say start. Register. It says register complete, and then start to is your username, email, and password is start. So now I can go to login. I can say start to, start, say login, and then boom, login successful. You guys get the idea, right? This allows you to design a user interface with login, and the database is hosted locally, right? When I say local, I'm talking about this file here. So the start at gmail.com, the password, now it's saved in here. If I remove this file, then guess what? If I launch the app again, then it won't work. Make sense? Any questions? Okay, so so now you guys have like the basic concept. Now if I say a RAG algorithm in ChatGPT, or if you drop a document and then it's trying to query some sort of document, now you guys have like a basic concept, right? So behind the scene, there's a database just like this, and then it's taking chunks of the documents, stored in the database, and then when you talk to it, it will take your query and then quickly runs through all of the query in the database and find the most similar one. And you won't be able to do that unless you have some sort of a local database stood up. Make sense? Any questions? Okay. Cool. Let's stop here, and then I can probably close this. Now, let me show you guys a few more things about Gradio app, and then hopefully it will help you guys get things started. And after that, we can probably call it a day. I'm gonna upload this on GitHub, by the way. So, if you forgot about it, don't worry about it. Everything here, it's pretty much, you can just run the whole thing and then you're gonna get everything off the shelf, right? There's nothing special here. You don't have to go from one website to the other. You can just run this in the notebook. I can show you this real fast. For example, I can click on this Colab notebook, and then you can just say run all. Hello. Hi. So let me zoom in. So this app is here. So how it works is Colab. Anyone use Colab before? Yeah. Okay, good. So Colab, I don't need to explain that. It's basically a Python notebook, right? The benefit here is it's actually implemented with Gradio on Colab, which is why I use Gradio here. It will give you an interface on the spot, pretty much with a few lines of code, and that's why this is beneficial. And then you can design any custom Python function. Let me show you guys a little bit real fast. It's super easy to read. It's highly intuitive. So in this case, I have a function. The function is called greet. It takes a name as input, and then you just concatenate with hello. Like my name is John, it will just say hello, John. And then the interface, it literally just one line of code, and I will give you this interface. If you enter a text, it will give you another text, and then the function is greet. So these three things is also highly intuitive. And obviously, presumably, you know that this function is a string going in, a string coming out. If you don't know that, then obviously you might make a mistake in the text and text, right? If the output is an image and then you wrote text here, then obviously that's not going to work, right? But anyhow, it's very easy to read this app, and then you can just type in whatever here, blah blah blah, and then you will say hi, blah blah blah. That's pretty much it. That's like the most basic thing about Gradio that I can tell you. The next level is some sort of like interaction, right? Let's say you have an image classification. Anyone here take the deep learning class? Okay. Anyone know what a convolution neural network is? Okay. So for those of you who don't know, a convolution neural network, or also known as CNN, basically you send an image in there, and then it classifies what the image is with the probability. So like cats versus dog, that sort of thing. So you can quickly build up that app, obviously assuming that you have a model behind the scene, right? Here, we're just using a model from Torch Vision, just simply because it's building and it's just easier. So you can quickly launch that. And then you should not need a GPU because, GPU will be faster, but you shouldn't need to because this is kind of like an easier model than large language model. So you can just click run all, and then it will quickly deploy an app using this model, AlexNet, behind the scene. And then when you run an inference, and this is when things get a little bit interesting. Let me highlight this code here. Okay. So this is when something gets a little interesting. So first of all, the data for a convolution neural network is image, right? Obviously, you can throw an image file into a model, right? You have to throw a matrix in the model. You have to throw numbers in the model, right? You can't throw an image file in the model. So the first thing that you see, when you read Python, you read the inner parentheses first, right? So that's the inner parentheses. So what this is doing is it takes the data and then it converts into integer 8. 8 just means byte size 8, like 8 levels. And then once it's at that level, we're talking about the matrix. It's no longer a picture anymore, right? It's a matrix of numbers. You send the matrix into an array, make sure data type is correct, and then you send the data into a tensor. Now it's consumable by the Torch model. So that's what the first line is doing. Any questions? Good. Okay. The second question is also very interesting. So once you have this image, Let me highlight this here. So this image on line 13, it's not the original picture file anymore. This image is just a bunch of numbers, like a matrix of numbers. So now you're sending the matrix of numbers. Again, how do you read Python? You read the inner parenthesis first. That's the input. And then you send that image into AlexNet, and then AlexNet is going to give you some sort of output, right? And then the output is going to be the last layer. So that last layer, you then send into softmax. Anybody know what softmax is? Well, yes. It's activation of the last layer. So you take the last layer and then convert it into a bunch of probabilities. And then the probabilities is called prediction. So line 14, this prediction is going to be basically a bunch of numbers that are probabilities. And why do I say probability? They have to sum up to 100%, right? There's no 200% probability, right? That's not a thing. I guess students tell me this before, like they're 200% confident that that they're getting an A in some class. That's not a thing. The highest confidence is 100%. That's it. So whatever number in here, they can be 0.01 to 0.99, and that's it. Anything in between. If you see a number here that's 2 or something, then that's wrong. So now you have probability, and then you throw that into this map function. What this map function is doing is it takes the probability and then look at the labels, and then it's trying to find the best one. When I say best, I meant the highest probability, and that's what the third line is doing. So that's what's happening here. And then when you get a dictionary, you should be able to get like the list of probabilities with the labels, and then hopefully there's like rank, and then you rank it by picking the top whatever. Here we're doing top 5, and then that's how the app is designed. Make sense? Any questions? Okay. So in some way, the inference is kind of like spelled out step by step, right? So that's what's good about this, because it really requires you to understand what's going on when people like run data through like a model, right? It really requires you to understand that. I would say the most important part here is image has to be numbers, and then once you send to that, it's a bunch of probabilities. Once it comes out of the neural network, it's a bunch of probabilities, and then you just sort them. That's what I would consider the most important thing in running the inference. And then after that, it's just an app, right? And then again, the app here is super intuitive. I have a function. Function is called inference. Great. What's inference? Well, inference is defined here on line 12. And then we just walk through steps. So you know exactly what's going inside of inference. And then the interface is very intuitive. Why? Because it asks for input and output, and that's it. And you know what the input is. Input is a picture. So this should make perfect sense. The output should also make sense. Output is a label, right? This is just a bunch of labels. So you just say label. So that's really it. There's nothing special about that, right? So now let's take a look at the final output. Can I take a picture? It might just take a picture of, oh wait, it might take a picture of me though. Yeah, I'll upload a picture. Here, how about this? Copy, and then, wait, I'm sorry, here. Is this one? I'll just upload. Yeah. I thought that would work. It's annoying. And then let's upload. Submit. What's a quail? I don't even know what quail is. Is a bird or something? What? Okay, that's definitely wrong. Yeah, that's definitely wrong. But cat, sure, I'll accept that. But anyhow, you guys get the idea, right? Um, well, the good thing is I did not train this model. This model is coming from torch vision. I'm actually surprised it didn't work because I thought cats is kind of like the most common object. Okay, anyhow, you guys get the idea of the design, right? It should be fairly intuitive. And then hopefully throughout this class, you guys will use Gradio to build pretty much different kinds of apps that you can send out by yourself. Um, that's pretty much it for technical content. Any questions so far? Okay. One last thing I'll show you guys, and I'll let you guys go. So I built this myself. You can, if you don't have an account, you can log in. I already have my account, so I'll log in myself. Um, it's basically a full stack chatbot I built myself, and I actually deploy on Azure. So you see Win360 search.azure websites. So it's deployed on Azure. And behind the scene, it's essentially a Gradio app. Anyone can register it. The benefit is I'm covering the API cost, so you guys don't have to pay for it. Otherwise, it's pretty much same with ChatGPT, right? You can talk to it, and then you can drop a picture here, whatever you want, and you can talk to it. Like for example, you can say, uh, the most fun exercise I do with people is using this, the California housing data. Like for example, I can say copy path, and then I can say, I have this data here. I want you to build a linear regression model for me. The target variable is called house. Actually, I need to know what it's called. This one, median house value. Okay, so median house value. Give me Python code to do this. Obviously, don't do this in your other data science class. I don't know what the professor will say, but but in my class, feel free to use whatever AI you want. And then you should be able to write a snippet of Python code for you and you just run out of the box, just like this. Very simple. And then you just take the code, and then this is on, right? Okay, so I'll put it here. I'll just put it here. And then you should be able to read data and then quickly build a model for you, just like that. Make sense? Any questions? Okay. We're coming out at 8 o'clock, and we can pretty much finish here. It's Friday. Only go to the bar when you're over 21. All right. All right, you're good. I'll see you guys next Friday. Yeah.